Research suggests that operators can process more information simultaneously if it is distributed across independent resource channels, considering how operators receive incoming information and what processing resources are used to understand it. Unfortunately, little guidance exists for designers who want to implement a multiple resource approach. If the multimodal puzzle is not correctly implemented, interference between cognitive subsystems may overwhelm users and cause information overload. If implemented correctly, however, information can be ideally distributed across all available resources so that overload situations are minimized. This is where the System for Multimodal Information Design Support, or short, MIDS, comes in. MIDS is a scientifically validated software tool that provides an accurate, predictive, dynamic assessment of operators' load across all resource channels. When predicted workload exceeds a theorized threshold, MIDS assesses what tasks are contributing to the problem and offers targeted design guidelines to optimize multimodal information displays at any stage of the design process. The MIDS process consists of 3 stages: creation of a task library and timeline for your unique environment, calculation of predicted workload, and output of design recommendations. Each of these steps is now briefly explained. To use the MIDS tool, it is necessary to understand all tasks in the environment that require operator involvement. These tasks are defined within MIDS by assigning specific resource consumption values, timing data, and relative task priority. A library of tasks is included in the MIDS system, and designers may select from this library and/or create customized task libraries for their unique environment. Information from the MIDS task library will populate a visual timeline. This detailed event timeline is the basis for MIDS predictive workload analysis. Next in the process, predicted workload is calculated based on the timeline of events entered into the MIDS program. The workload score assesses individual resource channel load as well as a total workload score that accounts for additive workload across channels, plus additional load imposed by multiple channels being simultaneously activated. Output from the workload equation is displayed visually on the timeline chart, where overload is represented by red vertical bars. In the example on the right, there are 3 distinct times of predicted overload. Detailed second-by-second workload values are also provided in a data file if more detailed analyses are required. For times of predicted overload, MIDS outputs targeted multimodal redesign recommendations based on ongoing tasks that contribute to high workload. Specific aspects of tasks are identified that should be redesigned to optimize multimodal information perceptualization. MIDS is applicable to a wide variety of systems with high workload conditions. Examples include military applications such as command and control environments or weapon control systems, but also civil entities like control rooms or surveillance systems. We at Design Interactive look forward to discussing how MIDS may be implemented in your environment to optimize multimodal displays and enhance operator effectiveness and efficiency.